me share first. Where are we? Okay. So, so in the first class, what we have seen that the difference between the open loop control system as well as the closed loop control system, right? The difference between them, open loop and the closed loop control system. These are the main two types of control systems, open loop and closed loop. And for that, we have seen an example of fan and some examples of open loop and closed loop control systems. Okay. So first of all, let's say what is the main difference? The main difference lies in the feedback. Open loop control system does not have any feedback. On the other hand, closed loop control system has feedback. So by feedback, by using the feedback, it can change. It can change the output. Means by using the feedback, you are that is taking the given input, the information of given input to change the output. Like first one, the open loop systems are simple and economical, and closed loop systems are complex and costlier. And open loop system has less power, consume less power. On the other hand, closed loop system consume more power. And the open loop systems are easier to construct because of less number of components required. So, and the closed loop systems are not easy to construct because of more number of components required. The open loop systems are inaccurate and unreliable. The closed loop systems are accurate and more reliable. And the stability is not a major problem in open loop system. Generally, open loop systems are stable, but the closed loop systems are not that much stable like the open loop system. And open loop system has the lower bandwidth. On the other hand, closed loop system has the large bandwidth. The feedback element is absent in the open loop control system. On the other hand, the feedback element is present in the closed loop control system. And output measurement is not necessary. In the here, the output measurement is necessary. The changes in the output due to external disturbances are not corrected automatically, so they are more sensitive to noise and other disturbances. The changes in the output due to external disturbances are corrected automatically, so they are less sensitive to noise and other disturbances. So let me check the types. So that is the control system. The main difference is that in the control system, we use the control element to make a system control system. So what we have seen, the elevator, which example of elevator. And see types of control system: open loop and closed loop, linear and non-linear, and time varying and time invariant. But here, first of most important one is the open loop and closed loop control system. Open loop and closed loop control system, we have to check this out. Then we'll move. Next. Now, see what is the open loop? Open loop control system does not have any feedback. Does not have any feedback, and these are the some advantages and disadvantages. Some examples are there. We have discussed this. That is the closed loop control system. It has a feedback. The closed loop control system has a feedback. Advantages, disadvantages are there. Some examples are there, like automatic electric iron. Heating elements are controlled by temperature of the iron. Some examples are there, like missile, autopilot system, computer numeric control sensing machine, industrial robot. These are the example of closed loop control system. Okay, now move on the time varying and time invariant control system. What are these? See, systems whose parameters vary with time are called time varying control systems. Look at the point here. Systems whose parameters vary, parameter changes with time, are called the time varying control system. The systems whose parameters vary with time are called time varying control systems. See, if you change the time, then the parameter will be changed. That is the difference. That's the main thing. On the other hand, in the time invariant control system, parameters do not vary with time, are called time invariant control systems. So two things. One thing is parameter is varying with time, that is time varying control system. On the other hand, parameter do not vary with time is called the time invariant control system. See, the mass of missile rocket reduced just as fuel is burned and has the parameter mass is time varying and the control system is time varying type. The simple example is here. The mass of missile rocket reduces as fuel is burned. It has the parameter mass is time varying and the control system is time varying time. It is an example of time varying control system. Missile rocket. Yeah, missile and rocket, those are the closed loop control system. But based on the parameters with time, we can divide the control system into two more parts with respect to time variance. Okay. So let me tell it again. The systems whose parameters vary with time are called the time varying control systems. When the parameters do not vary with time are called time invariant control systems. The mass of missile rocket reduces as fuel is burned, and hence the parameter mass is time varying and the control system is time varying time. These are the things. Okay. So I think you do understand what is the time varying control system and what is the time invariant control system. Right. I think you have understand the point. You do? You do understand? Okay.
Yes, sir. Yes, sir.
So another type is linear or non-linear. So to get a linear control system, it has to follow the superposition theorem. Superposition is what? It is something like that. Say x1 plus x2 is equal to y1 plus y2. Okay, so that means it has to be changed. And let's say if you add another constant, C1. That should be equal to C2. Same. This kind of thing is known as the superposition. Or if you do, say, x1 into x2, is equal to y1 to y2. This kind of systems are called linear systems. It changes linearly. Like here, okay, some parameters, it changes linear, something like that. Either input x1 produces an output y1 and an input x2 produces an output y2. Then any combination should produce an output. In such case, system is linear. Therefore, linear systems are those where the principles of superposition and proportionality are obeyed. So two principles are there. One is superposition and another one is proportionality. Linear systems are those where the principles of superposition and proportionality are obeyed. Superposition and proportionality principles are obeyed. That is the linear systems. Okay. So when an input x1 produces an output y1, and the x1 produces the y1, x2 produces the y2, any combination x1 plus x2 into y1 plus y2. x1 into x2, y1 into y2. So linear systems are those where the principle of superposition and proportionality are obeyed. So remember this thing. Okay, let's move on the next. Okay, and what is the nonlinear consistent? Nonlinear systems do not obey law of superposition. As simple as that. The stability of the nonlinear system depends on root location as well as initial conditions at input. Nonlinear system exhibits self-sustained oscillations of fixed frequency. Okay, these are the properties of the nonlinear consistent. Nonlinear systems do not obey law of superposition, and the stability of the nonlinear system depends on the root location as well as the initial conditions. So root location, we will go to that things later. When we will see the chapter 6, I think. Then we'll see the stability as well as the root location. Okay. So nonlinear Routh-Hurwitz criteria. By studying the Routh-Hurwitz criteria, ROUTH, Routh-Hurwitz. By using the Routh-Hurwitz criteria, we'll see the position of the root location. Okay. Since it is linear or nonlinear systems. And nonlinear systems exhibit self-sustained oscillations of fixed frequency. It showed a self-sustained self-sustained oscillations of fixed frequency. Okay, here the differences of linear system and nonlinear systems, like the open loop and closed loop systems. See the difference here. Linear system, it obey the superposition. On the non-linear system, it do not obey superposition. Simple is that. That can be analyzed by standard test signals. So we can analyze, and it cannot be analyzed easily. And the stability depends on the root location, and the stability depends on root location, initial type of input. 3 several things. And it do not exhibit limit cycles, and it exhibits limit cycles. And it do not exhibit hysteresis on germ resonance, and it exhibits hysteresis on germ resonance. And it can be analyzed by Laplace transform, Z transform, and it cannot be analyzed by Laplace transform, Z transform. These are the difference between the linear system and non-linear systems. So if I ask you to anything about the difference of these two, then I think you'll be able to answer the questions. As well as it may come in the exam that distinguish between the linear and non-linear systems. Okay, like the open loop and closed loop current systems. So this chart is important for you guys to understand or to memorize the difference. Okay. So next part, say, so we are moving from the classifications because classification parts are already done. Let's move on to the new term. Analysis and design objectives. Producing the desired transient response. So if you want to design a control system, then what would be your design objectives? Okay, let's move on. Let's see what should be the design objectives of a control systems. Like producing the desired transient response. First of all, you want to produce the desired transient response. Okay, so I think you have already seen the what is the transient response is. So if you do not, then let me write. That is the transient response. Okay. Next thing. This portion. This is called say 1 to 5. You want to go to the first floor to 5th floor. Here it becomes steady. So steady state response. That is a steady state response. And here is a gap difference. That is steady state error. Steady state. That is the steady state error. So two things are there. So one is the steady state reference, steady state response. Another one is steady state error. So two things are there. So first objective is to producing the desired transient response. So if you want to move the lift or elevator from first floor to 5th floor, then you have a target transient response. At this time it will be say T1. T1 time it will be stable, which would be the steady state response. And reducing the steady state error. So you want to reduce this one. You want to reduce the error. much as possible. So that is the second objective. The final objective is to achieving the stability. Okay, stability, you can achieve the stability easily. Okay, you can achieve the stability. But to understand the stability, you have to check out the chapter 6. We'll go to that later, that chapter later. So these things are what? These things are your objective. So producing the desired transient response, reducing the statistical error, and achieving the stability. Okay, these are the things you have to take care of to design any control system. So these are your objectives. So before designing anything, so you need some objectives. This is the objectives you need to consider. So what kind of objectives are there? First objective is to produce the desired transient response. Desired transient response, that means you have a target. So you want to make sure that your design system will work on the basis of your requirement. So second one is to reducing the statistical error, and third one finally achieving the stability. So we'll see a block diagram here. That block diagram will show us how to complete these things. So let's move to the next one. Okay, now antenna azimuth position control system. This is an interesting one. Antenna azimuth position control system. Another kind of control systems are there, that is the position control system. Okay, so move on. A position control system converts a position input command to a position output response. So if you give a position control system a position input, then it will change it to the output response. Like applications are antennas, robot arms, computer disk drives. These are the applications of position control system: antennas, robot arms, and computer disk drives. So you know, you are familiar with the antennas. That is a picture of parabolic reflector antenna. Rather, robot arms. These are the robot arms, and computer disk drives. Computer disk drives means the hard drive. Okay, hard drive is also a position control system because position is changing whenever you read the data or whenever you write the data in the position control system. The position control system converts the position input command to a position output response. Okay. Okay, here see. This is the potentiometer, this is azimuth angle input, and azimuth angle output. See here, that is the radar system. This one is the schematic diagram. You have a potentiometer. You can change the angle by rotating it to time, and differential power amplifier will move from the motor and potentiometer. See. Then whenever you change the angle here, then it will move the antenna. Here, see the gear systems are there. We'll see the gear systems also later. We'll see the gear systems also later. Okay. Now that is the block diagram of the functional block diagram of this position control system. First of all, you are putting the angular input, which goes to the potentiometer. or the input transducer, that is also called the input transducer. Then the voltage proportional to input will change. That means the voltage will be changed according to the input. If you change the input, then the voltage will also be changed. Then we have a summing junction. See, feedback, this feedback one is negative because we are comparing the difference of the input and output. What it does is taking the angular output. Let's say you are giving the 30 dB input. So according to your input, a voltage will be given. Now, the signal will go to the controller as well as the process, planner process. So controller contains what? Signal and power amplifiers, and planner process motor, load, and gears. Okay. So as a result, you'll get output. But it may or may not be the your desired output. So feedback is also working there. So the feedback will get the value and convert it to the voltage proportional to output. Then this value will be given to the summing junction and it will be compared. Plus minus. That's why it is plus minus. The input is plus and the feedback response is negative. That one positive, that one negative. The difference between them will help the owner or help the person to getting the desired response, desired output. Okay. There is a function block diagram. All things are explained here. And another example, see, boiler generator. There is another example, okay. Boiler generator. See, water going here. You are giving the feed water, fuel, and air, and there is a valve. And these three lines have the connection with the boiler. Boiler has a connection with the turbine and shaft, speed governor. And here, see, there's some parameters are there. You have to maintain the certain level to avoid the accident. So oxygen measurement, it will measure the oxygen. It will, the result will be goes to the computer temperature as well as the temperature measurement, pressure measurement. These three things. Okay. And the actual generation will also come to this computer. Okay. So here you'll set the values of temperature, pressure, oxygen, and generation. So if the computer see any difference with the oxygen measurement, temperature measurement, pressure measurement, then it will open or close those valves based on the requirement. Based on the requirement, they will open these things or close these things. It is a boiler generator example. And they explain it. And another one is the automobile system. The automobile system, what is happening here? That is the desired course of travel. And that is the actual course of travel. So he can observe visually by his own eye. Okay. So driver, steering mechanism, automobile, then the measurement, visual and tactile. Okay. Here's an example of automobile. Okay, so see, what is the optical playback system? Optical playback systems, I think you are familiar with it. CD player, DVD player, those things. See, home entertainment system also have built-in control system. For example, in optical disc recording system, microscopic bits representing the information are burned into the disc by a laser during the recording process. So information will be burned on the disc by the laser during the recording process. During playback, a reflected laser beam focused on the beats changes intensity. So whenever you read, then it will focus on the disc. The light intensity changes are converted to an electrical signal and processed as sound or picture. A control system keeps the laser beam position on the beats, which are cut as concentric circles. So this is the block diagram of the control system. I have taken this from the books, okay, of the Norman Nice. I've taken this one in the reference. You see here the laser diode, cylindrical lens, upping lens, grating, prism, 1/4 of the wavelength plate. That is a fixed mirror, and that is a photodiode. Okay, that is the optical plating system at a glance. Okay. So see the control system design. To design the control system, you need to have some goals. Like the goal of control engineering design is to obtain the configurations, specifications, and identifications of the key parameters of the proposed system to meet an actual need. See, first one, the step one, the determine a physical system and specifications from the requirements. Then draw a functional block diagram, then transform the physical system into a schematic. Physical system into a schematic, then the schematic to block diagram. And chapter 4, use step 4, use the schematic to obtain a block diagram, signal flow diagram, or a state space representation, whatever it is required. We'll see all. We have already seen a block diagram, but we need to see details again. And next one, if multiple blocks, reduce the block diagram to a single block or closed system. So if you have the multiple blocks, then you have to reduce. Chapter 5 and 13. We will discuss it in the chapter 5 and 13. And chapters 4, 6, 12, and 13. The last step is to analyze, design, and test to see that requirements and specifications are met. Okay. So this is an important block diagram, so you have to check it out. Okay, so we have finished the chapter. These are our references: control system engineering, Norman Nice, and the modern control system, Robert Bishop, Dorfman Bishop. Okay. So we have completed this chapter, first chapter. Then now I can give it to you. So you check this out. The first chapter. Okay. You have to check this one. So I think